Are you looking to transform your organization into a data-driven business? Are you exploring effective strategies for leveraging big data for business intelligence and analytics? There's one conference that delivers a comprehensive, immersive educational experience to guide you through all of today's key issues in data management and analysis. Data Summit brings together IT practitioners and business stakeholders from all types of organizations to learn about the leading technologies and strategies for succeeding in this increasingly data-driven world. You'll find unparalleled opportunities for peer interaction through panel discussions and provocative talks, and connect with key industry vendors at the Data Solutions Showcase. With tracks on digital transformation, competing on analytics, moving to a modern data architecture, as well as unique co-located events on cognitive computing, Hadoop, and cloud, Data Summit delivers timely insights and practical advice for data scientists, CIOs, system architects, and a vast array of business-savvy professionals. Join us this May at Data Summit 2018 at the Hyatt Regency Boston to network with the best in the business and chart your course forward in this rapidly changing world.
Welcome to today's Roundtable webcast, brought to you by Aerospike and Oracle. I'm Stephen Fegg, Director of Database Trends and Applications in Unisphere Rehearse. I will be your host for today's broadcast. Our presentation today is titled Leveraging Big Data with Hadoop, NoSQL, and RDBMS. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if it's you. Now, to introduce our speakers for today, Brian Bulkowski, Chief Technology and founder of Aerospike, and John-Pierre Dykes, Master Product Manager of Big Data at Oracle. For more information on our speakers today, you can click on the arrows next to their headshots. Now I'm going to pass the event over to Brian.
Thank you very much, Stephen. It's a pleasure to be here at DBTA webinar again. So today I'm going to talk about some of the experiences and customer engagements we've had at Aerospike regarding some exciting new trends in big data. In general, what we have been finding is that big data, having had a long resurgence within the Hadoop and back-end analytics, is starting to move very rapidly to the front edge of the enterprise. What we've seen in the internet in general over the last 15 to 20 years is the emergence of internet companies, such as you see on the right, and the very rich application frameworks and a very high availability and correctness that they provide. When you think of a company like Ola Cabs battling Uber, you don't really think about the taxi companies. You really think about the transformation that has occurred as businesses on the left become businesses on the right. An interesting example is company Bally's, which, as you think of them as building casinos and large buildings and being a traditional enterprise in that sense, acquiring the company Playtika on the right-hand side, which uses NoSQL for the really very rich applications, which are essentially slot machine and gaming devices in the palm of your hand, available outside the U.S. When you look at an experience like Snapchat and Facebook Messenger, it's all about communication, and communication is rapidly shifting from the Verizons, AT&Ts, and T-Mobiles of the world to these new systems. In order to create these rich internet applications, it's absolutely necessary to look at the database layer. What I have typically found is most people, architects who have been around the block a few times, know that the true scaling problem in any application is absolutely going to be the database. Data has gravity, and with today's cloud environments and microservice systems, which are yesterday's message bus systems, you tend to have the ability to spin up new nodes on a public or private cloud very quickly, but actually grow your database becomes the limit of scale. The problem with this, so let's take a look at what the database landscape provides today and how the shift has occurred to be able to bring these incredibly rich experiences to the front edge of applications in a way that can be used by traditional enterprises. What we had previously was a great gap between the OLTP and OLAP systems and an agreement that both of these systems were required, that we would need a transactional system, the quote money system that has every single payment, every single transaction, all of the fill requests, all of the cabs that are dispatched. And then we would also need an insight system, an analytics system to be able to guide the experience, to decide where to build, say, a new casino, to decide how to change the experience in subtle long-term ways. What we have found in the more recent systems led by internet companies is that unstructured data, which essentially is the ability to allow columns, new data types very rapidly and efficiently, has been taken over by a set of new companies, allowing untold experiences to programmers of great amounts of flexibility. Bringing in a new data type, a new column, a new record, a new type of data in an unstructured system is far easier, allowing the kind of flexibility that these companies have mastered. The big data analytics systems ended up being a parallel and distinct system and were driven by not only databases like Hadoop and what I would call traditional big database systems, but also systems that are essentially relational and table-oriented in nature, such as Snowflake that I chose here, but there's a number of others. And I think also you'll hear from Oracle today about some of their new products that are reaching into these levels of scale. Thus, the landscape is becoming blurred and honestly a little confusing, where we used to have a traditional batch analytics inherited system, but now capable of the petabytes and petabytes of scale that are capable, and a growing system on the right-hand side that I'm going to call analysis. I'm going to use this term analysis. Let me introduce it to you, because I believe what I've seen in the customer base and the user base is there's a set of actions, mathematical actions created by your data team that will allow you moment by moment, call it a recommendation, call it which cab to call that's local, which price to set, the availability of a given airline. Let's call that analysis for a moment, because it's no longer the kind of analytics that is done in these other systems. It's not a big SQL query. It is likely an AI or ML-based system as well, but it is really taking a relatively small amount of data. Perhaps it's only looking at a few megabytes or a few gigabytes of data to be able to sort out the recent behavior by others, recent behaviors within a audience cohort, and be able to right now on the front edge of the application create a customized and rich experience. So instead of calling that analytics and getting a little confused with our batch big data analytics systems on the left-hand side, which are absolutely crucial to big data, let me position or posit that this other thing, let's call it analysis for the time being. Now, since nothing's really new under the sun, there's certainly been plenty of systems on the right-hand side, from the CEP engines, streaming engines, etc., that have traditionally taken over for those systems. What's really changed is the ability to combine data, and that is the transactional data plus the behavioral data. Transactional data has a high-quality aspect. You can't lose it. You have to have consistency. You have to have full device commitment. You have to have two-phase commit. But you still need, the driving need is the ability to do that with speed. Most systems of that sort would end up creating either a caching tier, which means it's inconsistent, or a memory tier, which means it's small, or some other kind of compromise, which means that even though I have fast data, it doesn't have all of the power that's really required. And the second point is really about the resurgence, the growing need for powerful ML systems. At Aerospike, we typically see most of our customers are using, at least 50% have very high-powered, high-scale ML systems, and I'll show you how they do that. So the architecture that we see looks pretty close to what you see on this system. You end up having a database that is capable of not only correctness and consistency and a clustered environment, which means you can easily add systems. We're talking about a consistency guarantee that is as high as a traditional database with full device commitment, two-phase commit, a variety of different capabilities, but with million transaction per server capabilities, all the way through to a durable flash layer, not simply with a RAM cache. And the architecture you end up using on top of that to take those living insights and breathe them to life on the internet could be a system like you see on the left that has, say, SQL or Spark. SQL and Spark Spark has become very popular because it has a blend of capabilities of machine learning with MLlib, as well as the capability to take your existing code or your existing assets and programmers and have them be productive immediately. Aerospike now fully supports Spark and allows those kinds of systems to work without any form of application change. On the other hand, we also see that simply writing directly to one of these fast, consistent databases is absolutely practical as well. A traditional CEP engine often augments an individual transaction with data about the transaction. A STORM system in financial services may do exactly the same thing. With the advent of systems at this level of speed, you can now do that practically and reasonably without spending millions upon millions of dollars for a relatively small RAM-based system or have the complexity of a cache. In the capability of machine learning, let me draw a picture that was given to me by a customer, Nielsen Marketing Cloud. Nielsen acquired a company called Exalate, and they do a lot of work in ad tech and have built a very high-scale machine learning system. In this system, you find that machine learning needs to be able to reach out to any particular piece of data and will not generate something like a traditional SQL query. It wants to have a sensor ID, an audience ID, recent behavior, which fits very, very well with the NoSQL mindset. So in this architecture diagram from them, they first need to do some base classification and store all of the behavioral data in a data store. They then use that online to be able to do feature selection. This is your meta optimizer. And then push those real-time machine learning models into another database, which they also used Aerospike for. So the compute layer at this I haven't drawn, focusing on the database. However, it is really a practical way to get hundreds of terabytes online and active. We find this kind of pattern to be applicable in not just advertising cases, but really any form of retail that's relying on recommendations, as well as forms of financial services fraud prevention. Or as I like to say, wherever there's money, there's fraud. And so whether you're using a fraud service, which may be backed by Aerospike, such as, say, ThreatMetrics, which is one of our customers in online identity, or you're building your own by augmenting an online system with a system of your own, Aerospike is an excellent choice. The real point here is that there is now a blend between having the capabilities of a correct system, but also a very, very fast system. So typically that front-end transactional system was deeply limited in speed, and only could one trade off consistency in order to get speed through caching or simply the database settings. Thus, there was a vast gap in both products and use cases between these two. With the advent of NoSQL systems that are high performance, we've gotten to a world where NoSQL can now provide strong consistency, true linearizable capabilities of the traditional database while also providing sub-millisecond performance. There are some other interesting technologies in this area, but we do believe at Aerospike that the ability to do millisecond high accuracy systems, which are local to a data center, and using domain replication and disaster recovery to alternate data centers is a pattern that works great and Aerospike supports internally. Aerospike's capabilities in this area are backed by the work of the Jepsen Group, and you can go look at the Jepsen report on Aerospike 4.0 that has recently been issued that covers in great technical depth how we achieved the testing that was done by that group to whether Aerospike is delivering on these claims. Jepsen does not provide performance work that you can measure pretty easily yourself, but the tough distributed systems problems around node failure, how a node comes back online, whether there is any small timing holes, were probed deeply by this group. So what we believe is that there is an emerging class of NoSQL databases that are combining some of the best of unstructured data capabilities, both performance and flexibility, and edging into the 100 terabyte to petabyte systems that were typically only be able to be covered by the batch and analytics systems. For those of you technical in the audience, let me take a quick moment to talk about how we've achieved these capabilities. Aerospike has an internal hybrid memory architecture. So instead of relying upon RAM as the speed, we combine the fast update and parallelism of RAM-based indexes with a flash-based storage system that requires there to be only one I/O to an individual system, to an individual record in the database. We use the fact that that Flash provides very good individual accesses of different sizes, whether they be small or large, and doesn't require things like table continuity and has very fast random access. This gives you, on the primary key basis, the ability to do extraordinarily fast order 1 hash style lookups, but also allows us to do secondary index and column oriented lookups at very, very high speed as well. The ability to support rich data structures such as lists and maps within a record and thus get the consistency guarantee of a single record system is also critically important. What this means in production is being able to take, in this example, a Cassandra system. Cassandra is a already fairly fast, fairly scalable NoSQL system, and provide much, much higher availability and much, much lower predictable latency, moving here from a system that is millisecond at the 98th percentile to millisecond accuracy at 99.9. That radically changes what you can do in a business. Now, if all of this was ruinously expensive, that would already be covered by the RAM-based systems on offer by many other database companies and historically made within memory. Instead, Aerospike is able to offer this as a flash-based system, and we will typically go to a potential customer who may be interested and work out what your savings are versus the alternative for your specific use case. We often end up with any modest, reasonably large-scale deployment being able to save millions of dollars per year over either a traditional NoSQL, a relational implementation, or a RAM-based system. Of course, today, no discussion about databases would be reasonable without talking about the cloud. Aerospike does support bare metal, and we find that to be a continued deployment pattern. However, we often now see that it is a managed internal cloud, such as those created by Pivotal Cloud Foundry systems. Aerospike supports all 3 tiles within that, and Kubernetes systems, such as what we support within the Google Cloud Platform, are also widely available and supported by Aerospike. Many Aerospike customers are on public clouds as well, with AWS, Azure, and Google well represented. And a style of Aerospike where you can easily add nodes is an excellent choice. So I'm going to quickly go through, in the remaining time, a few interesting examples that you can see that hopefully will spark some interest. Fraud detection, I mentioned in passing. It's turned out that the ability of trading and risk positions to also butt up with fraud detection and risk management are a very interesting system because of the ability to look at trades that are in flight and thus a higher, more correct transactional view of the data. So not only can mobile users correctly see their system without the baubles that occur with a RAM-based system, but also you end up having the ability for risk management systems to look at the untraded or counterparty risk with pending transactions, which ends up being a very powerful capability, only really possible when you have a database that is much higher horsepower. With a fraud prevention system, you end up being able to handle hundreds of terabytes of data. I've ended up finding that fraud prevention is even a higher scale than, say, advertising use cases, and that the folks who use Aerospike in this way are really pushing the boundaries of scale for machine learning-based systems in particular. With retail systems, we find that the primary driver is integration with advertising systems and improving advertising spend, and at the very same time, on the very same data, being able to also provide high-quality recommendations. So these systems are often smaller than a fraud-based system. However, this whole trend, the big data in real-time system, allows you to start being able to combine all of these things. So you have a Customer 360 app, but then wouldn't you like to know if someone is coming in being fraudulent? Well, you might want to look at who your customers are and who your potential customers are as part of that process. This whole world now of being able to combine those data sources really gives some amazing capabilities. So in summary, we'd like you to keep in mind that the NoSQL systems out there that are Flash-based are really providing a new capability that is in memory, but it is all performance, but it also has the durability and consistency of traditional databases. So the ability to start blending together your traditional system of record style use cases, whether they be an airline reservation system that must be right, whether it is a transaction system with your pending transactions, or a retail system that is next generation with, say, delivery dates, times, and flexible pricing. All of those are now capable with a NoSQL systems. So that concludes my presentation. If you check the Aerospike website, we're a company that's been around for a while. We have a lot of interesting customer stories. If you'd like to find out any more, please take a look at our website.
Thank you very much, Brian. At this point in time, I'm going to pass the event over to our next speaker today, Jean-Pierre Dykes, Master Product Manager of Big Data at Oracle.
So what we're going to talk to about right now is how can we drive big data benefits for our customers, and I'll give you a couple of customer examples. We'll round that out with some key trends, because what do customers do today, what do we do next is, I think, an interesting paradigm to look at. In terms of how do our customers do that, we'll talk about our reference architecture, and then we'll talk a little bit about like some contrast and where do you put your data. And again, I'm looking at this very much from an analytics perspective, and I very much want to look at this from a kind of black and white, what do we think, what do we see, and kind of go from there. And then we'll just end up with how can we as Oracle help you in these cases. So let's start off with, again, something we talked about in the previous session here. What does the internet do? And here we're focusing on like a company called wargaming.net, and what they do is a multiplayer platform game, and their intent is to have all players play for free. But obviously, they're a commercial company, so the goal is really to figure out what are the characteristics of people who then go really play a lot and then start to buy things, and it's kind of the classic idea that we see in commercial companies of upsell, cross-sell. And just one of the things that they did, and what they did, by the way, is they used SQL on the Oracle side and R analytics on their Hadoop cluster. They take all of this telematics data from these games and then drive changes in the applications. One of the things they realize is that if some of these consumers or some of these players do particular tutorials on these games, they're 75% more likely to actually buy something. But if they don't follow this tutorial, and it turned out someone got stuck on step 2, they only end up with 33% chance of buying something or moving along there. And so they actually went in, dug out this telematics data, fixed the tutorials, and then they drive all of these people through these tutorials and actually made that successful. And so here you see how data directly influences, and data analytics directly influences how you kind of change these games and how you drive behavior. And so they got all these users to go from a 33% likelihood to 75% likelihood. Now, the next one I want to quickly talk about, and this is actually Airbus, and this is testing for their A320neo. You can see the 30% reduction in test time there. This is really about making sure that after test flights, I get my data quickly, I can analyze things. And here, Airbus actually uses a NoSQL database, in this case, Oracle NoSQL database, on an Oracle engineered system. I think one of the interesting things here is that Airbus very much is capable of building extremely complicated systems, highly available, right? They build airplanes. Yet they didn't decide to go and build their own Hadoop clusters. What they very much decided to do is mitigate their risk on that one and buy these systems off the shelf, pre-engineered, optimized for their use cases, and then leverage Oracle's expertise to essentially solve those problems for them. So don't assume that while you're doing very complicated things, you should also be in the business of engineering IT systems. And I think that's what Airbus really does. Last one that I'll talk about briefly is CaixaBank, one of the largest retail banks in Spain. And the interesting thing of Caixa is A, that they bet very big on technology and data, but B, how they did it. From a CEO level down, what they decided to do is completely redo their analytics environments. They removed all data silos. They declared all data available to all bank employees within, of course, regulations and security, but then drive the value, and you see again 50% sales increase on targeted offers, and drive all of the analytics value and all of that directly from what they call their data pool. And this CEO-driven initiative, I think, is really crucial to their success. They built up this platform and made the bank truly data-driven. And I think it's highly interesting to see these customers implement these systems. Now, if we switch context and look forward, right, what are some of the things we're seeing some of these customers look at, but generally speaking, happening in the industry? One of the big things, and I've kind of paired them up here, one of the big things you're seeing is that not only has budget kind of shifted to the actual users, they also drive how they want to pay, what they want to pay for, and very much expect to pay for when you use things. And that, of course, drives a lot of the movement to cloud and a lot of the big kind of pivot to cloud. Now, the one thing I wanted to call out here is that as we have these complicated and complex systems, I don't think, or we think at Oracle, that cloud shouldn't just be, I'll take whatever I have and put it in cloud, and now life is great. But we think it's very much a pivot that goes much further. And it goes to like we call autonomous systems. Some people call it autonomous services. Some people talk about managed services. But it's this whole shift to a utility computing model, and I think that is going to be extremely interesting. But don't just assume it's lift and shift. What we start to see is, and Brian talked about that as well, as analytics and analytics on the edge and all of those things. And we believe that drives an important trend from a data architecture perspective to consolidation, to understanding and standardizing your platforms, to your data, as well as your languages. And so you'll see a pretty significant impact and shift to data architecture is becoming extremely important from a scale and performance perspective to drive the analytics and to enable these advanced techniques to go into like your typical BI. And then I don't have to probably go into much detail here, but regulation as well as security and governance are a very, very big ticket item. And so I think these are very exciting, but there is definitely some interesting challenges coming along. And so with that, I want to quickly talk about Oracle's reference architecture. This is our end-to-end information management reference architecture, and here we focus on the analytics side of it. And we can talk 20 minutes just on this slide. But from a conceptual perspective, I think what you start to see is four kind of major components. Data streaming, which is a big thing. The data lake or data pool or whichever lake is, whatever word is kind of in fashion these days. And enterprise data and reporting. And while I haven't put NoSQL on this classification in the next slide, I think you'll clearly see it, and from the previous presentation, you clearly can figure out where it's going to go here. Now, we also have this thing called Discovery Lab and this kind of wonderful red line. And what we're implying here is not that there are separate physical structures. What we're implying here is that there's logical components, and one of them is data discovery. And what we would like to very much achieve in our information reference architecture is for people to do discovery directly inside their execution frameworks. So your production Hadoop cluster, just to pick on one, would host your discovery because we don't want people to start moving all these massive amounts of data around. And it also helps with this bimodal IT notion that Gartner talks about, where your innovation is done inside of production, and therefore you can very quickly iterate from innovation to execution to innovation to execution. There's much more to this. You can look at our reference architecture on our site. There's some links later on that will point you at the right direction. From a practical perspective, these are some of the technologies we're seeing. Kafka, obviously a big newcomer in this. What I want to talk about briefly is this like object store or Hadoop HDFS kind of wonderfulness. We think that in cloud, going forward, object store will play a major role as the data lake infrastructure. Will that happen immediately? It's going to be a transition, like anything's going to be a transition. But we think object store in cloud is going to be the native data lake underpinning. On premises, however, it's extremely difficult to build a real object store and to have all these replicated systems up and running, to have this massive infrastructure behind it. So what we think is going to happen on premises is a focus on HDFS for quite some time to come. And so it's a little bit of both of these are going to interact. Now, one of the things we realized a couple of years ago at Oracle is that we basically are saying and accepting a reality that not one system will have all of your data at any given point in time. We have a set of data repositories, and I like the gravity word, right, that actually do contain that data. Now, how do I enable an organization to actually deal with that data? And one of the investments we made at Oracle is to franchise, federate, virtualize that data and enable any consumer from, let's call it a SQL interface at this point in time, to get to actionable knowledge, right? And that combines metrics, data sets, events, all in a singular SQL layer. And so that gives you a bit of an idea as to how we look at an architecture for information management and why we kind of say this is really containing a number of technologies. That instantly drives many people to ask the next question, which is, okay, but what data do I put where? Or how do I figure out how I go to which one? Right, and I think what I want to do is make this very simple. And so there's lots of nuance to this, and there's many gray areas, but I think it kind of helps to put these in stark contrast. And I think there's three things. One is the performance that is required. I think that came out loud and clear in the previous presentation. But if you need sub-millisecond latency things, there are specific systems to do so, and that's where you put your data. That overrules, which is kind of interesting, security, right? If I cannot deliver the value of the application to the consumer at the point I need it, then I shouldn't have that whole application in general, so it doesn't matter whether it's secure or not. I can put data in a bank vault and nobody can get to it. It's very secure, right? But it doesn't solve my business problem. So performance and achieving that appropriate performance for that workload is really critical. Then security, and then cost. And this one always gets people to try to read all of this. This is a nice kind of visualization to talk through some of these points. And it's less of a, here's the things you have to really worry about. It's more of a think through the basics of these systems and understand what your workload is. And if you need complex SQL query at very good response times, there are certain systems that do a better job than other systems. And the spider graph is not intended to say, oh, this is 4.5 and this is 5, right? That's not the idea. The idea is to kind of quickly sketch down, hey, these systems are good at these tasks. And we kind of classify these, and there's a number of these in here. We classify these as kind of affordable scale for HDFS, low predictable latency for NoSQL, and flexible performance for the RDBMS. But I think that's a pretty decent guideline if you're looking at, hey, I've got an application, I'm looking at information management, where do I go, where do I start, where do I put my data? And so hopefully with the information management reference architecture in mind, this helps and guides where to put your data and what you use where. Now, imagine you say, wow, this was really great. Where do I go? What do I do next? And so let's talk a little bit about how Oracle fits in this picture and how we can help drive the value you saw out of these other customers into your organization as well. We focus on two things. We focus on simplifying IT, and we focus on then simplifying the data. Right? How do we make your IT lower cost, but most importantly, optimized for your workloads? How do we make that simple for you? But how do we also make sure it is secure by design, you have high availability, you drive the performance you need, and these are the core tenets to Oracle solutions. Right? How can we simplify this while giving you all of these enterprise capabilities? And then once we have that infrastructure in place, we worry about simplifying data. And what I mean with that is, how do I unify this data? How do I give you a 360-degree view of your data? How do I make sure you're compliant? How do I get the security all sorted and have that at the data layer? And then how do we make it actionable? Right? Whether you push it into the NoSQL read cache, whether you push it into an Oracle database, how do we do this? How do we make this really drive what an organization has to do? I talked about cloud, which naturally means there's also on-premises, and I want to briefly kind of highlight how we look at that again from a delivery and deployment perspective. So here we focused on the big data side of the products and solutions we have, but you can draw a parallel to relational database, to all of our cloud and PaaS infrastructure. We do essentially the same thing. I think everybody will, of course, understand public cloud, where we deliver all these solutions. We also deliver, of course, all of these solutions on premises, and it's really the same infrastructure, the same architecture, the same standards, and the same kind of unified management environment around these. And I think these make sense to everybody. The middle one might kind of get people scratching their head and go like, cloud at customer. So cloud at customer effectively drives our public cloud stack into your data centers. But you will have the systems managed by Oracle, and you pay these systems essentially as you would consume cloud. So it's an OpEx versus CapEx discussion. And what you get from that is, like I said, a lot less risk, but you are compliant to many regulatory things. My data has to be in country. My data cannot leave my data center. There's various of these rules and regulations. Or sometimes I'm not quite ready to go public cloud, so can I have the benefits of cloud, but can I have them within my data center, and can I still install my software on here, et cetera, right? And so that's what cloud at customer brings to the table. And here you see this whole simplify IT business coming to bear from an Oracle perspective. You choose the deployment method, and we make sure it's optimized, it's the right architecture to solve your problems. From a strategic perspective on the big data space, right, I talked about how we see data landing in Kafka, how object storage or HDFS are a key data lake component, how a relational database drives a lot of the analysis, and you heard before how NoSQL drives these low latency read cache workloads. But how do I, as an environment, as an analyst, how do I understand and look across all of this data and make sure that I can see my entire business in its entirety, right? And that's, like I said, we built Big Data SQL. And the unique thing of Big Data SQL is that we control the query end to end. So mostly we talk about SQL, but you could run R over this, you can run Python, you can do a REST call, etc. But we control and run the SQL query across all of these tiers. And so you can combine in a single query, leveraging all of Oracle SQL and all of Oracle security, data in Kafka, NoSQL databases, obviously Oracle, as well as the Hadoop stack, and just join, union, query all of that. And we think this is one of the strategic products going forward. One of the important things in the big data landscape is to be able to unify your information. And like I said, this is a critical part of our reference architecture and a pretty cool capability in terms of delivering value and information to consumers. So that gave you a kind of whirlwind tour through some of the customers that we work with and some of the benefits they drive. And hopefully one of the things that you kind of take away from this is that it is critically important when you design information infrastructure to choose the right system to do the right thing. Right? The right tool for the right job is critically important, but it shouldn't be a discussion of either or. Like we think that you look at these new technologies, you leverage them appropriately, but you don't choose one over the other. You'll combine most of these because it is kind of our belief that not everything does everything equally well. And so unifying these technologies is very important, and understanding what they're good at is very important. And then driving to the right information architecture, because that really ensures that analytics, information access, security, and governance are really critical here. So with that, there's a number of links here that I think are interesting to look at. We write a blog out of development where we actually share a lot of our best practices, a lot of our tips and tricks. That's the first link on there. And then there's a lot of other information that you can obviously find at oracle.com, cloud.oracle.com, and some of the links over here. And with that, I'll conclude my presentation, and hopefully this was useful, and I'm looking forward to the discussion on the Q&A.
Fantastic. Thank you very much, Jean-Pierre. At this point in time, we are going to dive into questions from our viewers today, and the first question is for Brian. Brian, do you lose some data fidelity with NoSQL?
Yeah, that's a great question. And having been involved in NoSQL since the very beginning, the initial NoSQL conference that occurred in Atlanta, I can say that I agree with Michael Stonebreaker's position that it takes at least 10 years to build a high-quality database. And so we have seen all of us who wanted to participate in this new world of creating a new class of databases work year after year to increase data fidelity. We saw, for example, MongoDB. I will give them credit, absolutely, for also passing a Jepson test and providing a high level of data consistency. However, eventual consistency systems, or systems that don't flush properly through to an underlying data store, persistent storage, really have a lot of flaws. So we've addressed that at this point with Aerospike. Believe we've come into our own as a database, and it's an important aspect to look at is a NoSQL solution that provides both consistency but also perhaps availability modes. They're both parts of the equation. So take a look at your NoSQL, find out.
Understood. Thank you, Brian. Jean-Pierre, our next question is for you. The examples you were showing before, were those all based on Exadata architecture?
Not all of them, right? I mean, I think what we looked at from an information management perspective is really a combination of Oracle SQL Engine and then various storage tiers. Most of those customers actually leverage Hadoop, NoSQL, and Oracle database. What we did do is we ensured the high performance of Exadata is driven into these stacks through Big Data SQL. But the big cool thing of Big Data SQL, I think the audience picked up on, is that we leverage the techniques of making an Oracle database on Exadata fast on all these other platforms. And we took the Exadata storage server software and effectively deployed that into, for example, the Hadoop stack. And that gives us end-to-end query control as well as security control over that data. And so Big Data SQL does leverage the innovations of Exadata to speed up queries on schema, on read data, on unstructured data, and plays the same tricks of I/O avoidance. And that is a key differentiator to the Big Data SQL solution, really driving performance on top of unstructured data and various other tiers.
Understood. Thanks, Jean-Pierre. Brian, our next question is for you. I have been reading a lot lately regarding NoSQL applications across SOR, SOE, and any thoughts?
Yeah, that's a great question. The traditional blend, I think, of this system of record, that's SOR, SOE, system of engagement. It's funny that I hear analysts talk about this system of engagement more than I hear people deploying them. An architect will usually say, well, I need this much data correctness and consistency, and I need this much performance. Performance is your level of engagement. How much data, at what scale, can I put hundreds of terabytes on the interactive and engaging part of my application versus how correct is that data? So this new blend of bringing together SOR and SOE and SOI is really all about new database capabilities. And I think hopefully folks coming to DBTA are really interested in the kind of new and innovative products that are breaking new ground in database research about how to bring those together and the business impacts they can have.
Understood. And, is Aerospike considered an engagement database?
We tend not to use that terminology, to be honest. I think that the architects and business people understand they need more engagement, and having performance and correctness in that database is key. So I wouldn't object to that, but we don't use the term ourselves. We are great for creating engaging experiences.
Understood. Thanks for clarifying. Jean-Pierre, our next question is for you. Isn't the Oracle Engineered Systems solution for big data more expensive compared to open source on commodity?
That's an interesting one. I guess it's maybe a natural assumption. I don't know why we have that, but so from a big data perspective, just to dive into this a little bit, we actually leverage and package the entire Cloudera ecosystem, and what we do is we include that license cost or that software into how we packaged up our engineered systems as well as our cloud services. And so what we think is, and there is analysis on the web on this as well, is that we actually have a very competitive and compelling solution because we actually make sure that we have a very highly available infrastructure underneath it. We use top-notch components, and we drive systems that have very high performance but at a Hadoop competitive price. So I think we kind of combine the best of both things. You get the lessons learned on engineered systems from Oracle cast into these systems at price points you would typically see from commodity vendors. Obviously, pricing is always an interesting discussion, but obviously you have to look at apples versus apples and not versus oranges, and so you would have to include all of the costs and whatever to calculate your system cost. But we think we have an extremely compelling, and that's what our customers tell us, an extremely compelling priced offering for the systems we deliver on that. So I wouldn't call them more expensive. I think they're extremely valuable and extremely price competitive.
Understood. All right, Brian, our next question is for you. On slide 6 that you showed us, the Aerospike database connects directly to AI engines and CEP engines, but connects through a framework for Spark. What does Aerospike do specifically for Spark?
Yeah, that's a great question. Aerospike has created a great connector for Spark that we call the Real-Time Analysis Framework. It is capable of using Spark or playing in the Spark landscape with the kind of data federation that Oracle just talked about. So we also believe that there's capabilities of different databases. Aerospike's primary capability is essentially the hash join database, and that's really important within a Spark framework. So you can essentially create an individual table, link other databases such as Oracle, such as Postgres, etc., and execute single queries across multiple of them without having to import your data into RAM in Spark, but just go out. This creates some really interesting architectural capabilities to be able to access your transactional data in concert with the other ones, simply using Spark that you probably already have deployed. So with Aerospike's RAF, Real-Time Analysis Framework, we can do all of that. However, with ML, we also see, honestly, at scale, people simply rolling their own layers. So instead of using a framework and getting off the ground with no coding, in these early days of enterprise ML, a development group will simply be tasked with building a data store, like I said, of different of behavioral or IoT systems, and simply using off-the-shelf or custom-built libraries to generate results. And that's an awesome way to be able to create a scalable solution as well. So you can either take a package or you can roll it yourself.
Understood. Thanks, Brian. Jean-Pierre, you touched upon this before. With respect to cloud and object storage, does Oracle see HDFS going away at some point in the future?
So, to some extent, I think to be controversial, the answer is yes. but I think like I mentioned this before as well, but I think it's good to repeat and clarify. I think we will replace, not we as Oracle, but in general, the industry switches to different technologies once something is clearly better at doing a task. And I think in cloud, and the way an object store is actually created and managed in cloud, with its resiliency architecture, with its multiple zones across continents and all of those things, right? It actually takes a lot of the HDFS lessons and applies them at a much, much broader scale. So in cloud, in the future, we think that HDFS is not going to be the answer. It is going to be object storage. But like I said, in the on-premises world, which a lot of data still lives today, it's extremely complicated to build that object storage, right? And even if it was simple, there's a lot of investment that has to go into this. And on-premises, HDFS happily does all the right things. And so we do think that on-premises, we see HDFS living for quite a period of time. I typically guess wrong, but I would say it's multiple years where we see HDFS, specifically with the new Hadoop 3.0 version being deployed and coming out. I think we see HDFS having a life for quite some time to come. And then it's up to us from a software perspective to make sure that customers can transparently use those two as they see fit and as they build up hybrid solutions. And it is up to us to make sure that the migration, if we call it like that, from an on-premise HDFS world to a cloud object storage world is nicely done, and that's what we're hard at work at.
Understood. Thanks for clarifying. Brian, our next question is for you. What special preparation of data is needed for Aerospike to process data for machine learning?
Yeah, data preparation and data cleaning is a very peculiar topic within machine learning. So Aerospike doesn't need any particular answer. So we either in a Spark environment, you can simply route data directly into Aerospike or whatever streaming system you have. If you have Kafka, for example, you can simply dump that data into Aerospike. The fact that Aerospike provides a very high level of scale means that you don't have to do as much cleaning as you might otherwise. What you typically like in an ML system is for the models themselves to provide their own guidance and decide essentially for themselves which data is actionable, which data is correct, and fetch it point by point. So by having a very large-scale system, a 50 tera, 100 tera, 200 tera, even peta-based object system right at the fingertips of your actionable ML system, you push all of that in, say with our Kafka connector, you run your ML directly on top of it, and the automatic feature selection of your high-level portions of ML as well as your low-level models will take care of what's correct and what's not correct in your data set.
Understood. Thanks, Brian. John Pierre, next question is for you. There are a few data virtualization solutions in the market, so why consider the Oracle offering?
Interesting question. So we talked a little bit about the Exadata paradigm, and I said we control the entire query. So specifically, if I talk about big data SQL, there is two big functional things. One is you get to run all of Oracle SQL, like anything you ever wrote in the past and ever will write in the future, which is a pretty bold statement, right? It means we're fully 100% Oracle SQL compatible because we run the Oracle SQL engine to do this virtualization. And that sounds really cool technically, but that means that anything that has ever written a query to Oracle needs no changes whatsoever to its SQL dialect. Because we use the Oracle SQL engine to implement our federation or virtualization techniques, you also get the entire security stack. What that means, for example, is that you can do virtual private database, in other words, row level, column level, cell level security, using Oracle SQL on a Hadoop system. So you get to transpose a lot of these characteristics people like from the enterprise Oracle database capabilities directly onto a very disparate storage stack, right? Hadoop doesn't necessarily have all these capabilities, HDFS, even with Sentry or Ranger and Knox, but you don't have that fine-grained. NoSQL databases have various other ways of solving some of that. And here what we do is we project an image on top of that, think of it like that, and give you all that security. And then the third bit that we talked about earlier in the call is because we control the end-to-end execution of the query, we don't have to rely on, for example, something like Hive or Impala or various other SQL engines for performance. We connect this all up to the direct Oracle execution engine, right, and that drives the actual performance using your optimizer and all of those techniques. And so we think that we have cracked one of the most important ones, which is performance, and then layered on top all of the security and SQL access to that data, which I think is extremely compelling for our customers.
Understood. All right, we have time for one more question, Brian. What do you think of Elasticsearch versus NoSQL?
So, hey, I'm a big fan of Elasticsearch. I think that the architecture they have for clustering and supporting a broad variety of indexing forms is really an interesting, great piece of innovative technology. What I find our customers doing is the ability to index in Elasticsearch and then place pointers to essentially document IDs within a true NoSQL system that is essentially row and document oriented. So I think that Elasticsearch is in fact a great corresponding technology when the indexing you need and perhaps the complexity of indexes and performance is not provided by the individual NoSQL solution.
Understood. Once again, I'd like to thank our speakers today, Brian Bolkowski, Chief Technology Officer and founder of Aerospike, and Jean-Pierre Dykes, Master Product Manager of Big Data at Oracle. Now, if you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you'll receive an email tomorrow once the archive is posted. Plus, if you would like a PDF of the presentation, you can click on the resource icon at the bottom of your console. Now, as I stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is Tom Kelly. Tom, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.